All right, I think it is a good time to go ahead and get started again. Hope everybody enjoyed their 2-minute break.
Hey, I did manage to get up and stretch.
That's important. Yes, I hope everybody got a chance to stretch. All right, well, Beth, I will go ahead and turn it over to you. So thank you so much to Beth from Verizon for moderating high availability networking solutions.
So thank you, everybody. So I encourage everybody, I put the link in the chat, but I think it's available in other places as well. So I encourage everybody to jump on and put their names in. So this session, and Chris is floating around here someplace as well. Oh, there you are, Chris. So this is co-hosted by Chris and myself. So this session is focused on high availability networking solutions. And I think one of the first questions I have to ask is, what does high availability mean from a network perspective? So you'll notice I have some questions to get started. And I think the first question is, what does high availability mean? You know, where do you do it in your infrastructure? And I'll share what it means to me a little bit. So high availability in my world, particularly around networking, means failover to multiple other instances. So in the case of a firewall, we typically have a failover, regional, multi-regional failover, so that if literally if the data center goes down, not that that normally happens, but it could, backhoes do pull cables, then it will fail over to another data center. So extreme high availability. So that's, I want to open it up to others.
Thanks, Beth. This is Chris.
Yeah.
Just wanted to chime in. Been lurking here quietly, but high availability is interesting. I don't think about high availability in the data center. Actually, I think the data center becomes it becomes a little bit opaque as to how high availability is built. When we used to build high availability applications, it was down to the point when we knew we were running on batteries, for instance, was how we were programming things to make sure that there was no way the application could fail. And the cloud kind of removed that and changed the paradigm of what is high availability anymore. And it's been abstracted away, I think, to some extent. And it's good to have a conversation like this, because what is below the abstraction and what do I need to consider when I'm planning a high availability solution changes, and it continues to change. Now when you throw Kubernetes on top of OpenStack, then the abstractions just become even more so, and planning and defining high availability becomes even more of a challenge. As you say, backhoes exist, cables get broken, data centers go offline, so thinking that ingress is going to solve my problems is maybe dreaming a little too much on what you can get from the infrastructure and platform layer. But I think it'd be good to hear from others.
Sure, Chris. I'll bite.
Yeah, go.
So this is Arkady Koneski from Dell. So we have been, when we developed our first OpenStack solution, God knows, 7 years ago. So we kind of looked at the high availability in layers. So what I mean? Well, first is that from the hardware point of view, you have multiple redundant components. So from the networking point of view, means that you have dual data switches, each of the servers connected to both of them. From the if you look at every server have multiple NICs and multiple ports on them, such that we do the bonding across the 2 ports on 2 different NICs, and they are connected to different switches. So that means that failure of any single components will not take you down. It
But
might
that's
degrade your performance.
extremely expensive and very wasteful.
Agreed. But it's so you're bringing up the point is when you are looking at what I would call the high availability or resilience in general. What is the level of the fault tolerance you are interested in handling? And based upon that, you kind of build your solution based upon that. Yeah. If you're so this is kind of from the hardware point of view. Go level up, you have each of the components, for example, multiple, the triple controllers, which is becomes standard in the Openstack. You have multiple, compute nodes, multiple storage nodes, multiple controllers, such that any failure of any single thing does not take you down. And then there is a resiliency within each individual node, which is monitoring each of the services running of the platform services. And when any of those are going down, it will restart them, or at least try to restart them in a different level, depending upon what kind of failure it happens. Again, this is extreme. I don't disagree with you, but again, it goes down to when you look at the high availability, or to be more fair, resiliency, you go in layers and you align to what is the model of the failure you're trying to handle.
So let me, okay, somebody else.
So I'm sorry, this is Eric. I just wanted to pipe in on that, just in terms of it being an expensive option versus single connected things. We single connected things for a long time, and still have it that way in a lot of places, but not doing it in a sense is more expensive because it makes upgrading switch infrastructure significantly more difficult, causes outages when you have to do it. Single switch croaking causes issues, with things. People, are running replicated things on our cloud, and so when stuff like that happens, a node loses connectivity, you immediately split brain their database. And they tend to get upset about it. And we also run a lot more lights out data centers where we don't have anybody present there except for, some guy that we can call to go out and move cables. So having that resiliency in the network is really kind of critical for us. So we started running, dual MLAG trunks on every host, and it's been worth doing, I would say.
So let me add some comments. So this was a few years ago. I worked on an OpenStack implementation that was it ended up not going anywhere, but it was supposed to be a really large one. And I had a long argument with one of the architects about how many switches should we put at the top of rack, and they wanted to put dual top of rack switches. And my argument was that if you treated the node, the rack, as the failure node, you would save yourself, and I did some back of the envelope calculations, that it would save them about $6 million in not having to do dual top of rack switches. That was, I think, something that they had a hard time understanding. And I think they were very nervous about taking the rack as a failure node. So just some comments on that.
I think that's okay in a manned data center, for instance, but you've got to be able to accommodate the loss of a rack and then recover that rack in a timely enough fashion. A remote
in a large data
solution.
center, that's okay. It's not, if it goes down for 2 days, who cares? And then somebody can show up and, do whatever it needs to be done to fix it.
Yeah. So really, it's about adjusting to scale. It's cost versus scale, right? How much can you afford to lose on a failure, as far as capacity is concerned, in those kinds of equations?
Yeah, and Sig's adds his comment. Yeah, rack level failure, and I think that works best in the large scale data centers. I can't say for sure, but I'm pretty darn sure Amazon probably assumes rack level failures. But where it gets trickier, I think, is at the edge, where you don't have as much resources. So getting back to network, at the edge, you're relying on multiple network paths. Can you assume you have multiple network paths to save yourself?
Exactly. Where on the loop are you, or where on the ring are you? It's and that's interesting. I mean, if we roll the clock back to before we were trying to virtualize things, and you built your ring and you had a bunch of equipment there, and everything was in dual pairs, and as you then start to virtualize things, and we start to see virtualization of optic switches and optics into the data center, these sorts of things can even change the paradigm of how we handle high availability in the physical layer, which I think is actually super interesting, and even though it's been around for a few years, quite early in its life cycle. But it's hard to do anything HA without at least physical redundancy, and then how you apply software redundancies and the capability to take advantage of that on top is I think a moving target in today's games, at least on the research side. I don't know if anyone's looking into those sorts of things where you're bringing dark fiber into your data center and then essentially handling it from there.
So just 2 comments. We're going to be starting a poll, Aaron, on pain points around large deployments. So feel free to fill it in as we go. So Aaron, that's your cue to start the poll. So I'd like to circle back to the network itself. So obviously I'm speaking from a telco perspective, and network redundancy is something that I'm very comfortable with. And when we talk to our customers about network redundancy in high availability, what I find is we're talking about something that is beyond what a typical customer understands. So, for example, in good data centers, high availability of the network includes multiple providers and multiple entry points into that data center. And that's just telco thinking that high availability means 6 nines. However, most enterprises don't really think of it that way. And how can software-defined networking and large-scale deployments address that very expensive solution? Is there a way to address it? And I am opening it up to the community.
Hi, it's John G here. I just wanted to, Dave was also mentioning we're having a little miniature Ethernet chat, Etherpad chat rather, Freudian slip. Yeah. And so we were talking about the problem with applications, because often you don't really get, depending on the cloud, you sometimes don't get to influence the applications being run on it. in that particular case, how do you make sure that the system, like for example, is it cheaper to actually pay for those extra switches than try and restrict the applications running on your cloud? But I'd be interested to see if there's SDN fixes for that too. That was line 48, 49.
Yep. I mean, how many people are using, within the data center? So moving on to, so some of the other questions are you in fact concerned with network failures in your environment? Is that even a problem? Do you think that, having diverse pipes from AT&T and Verizon into your data center, is that sufficient?
Yeah, this is Eric. I mean, we've always had diverse pipes into all of our data centers, and run BGP. Honestly, for from a bandwidth perspective and cost of carrying something like that, it's insignificant enough relative to the cost of a complete outage that it's always been worth doing. And it kind of circles back to the same thing about using MLAG. Honestly, now I think about it, really, we're not using any more switch ports, or just slightly more switch ports than we used to in a single connected environment. It's just that we have an extra switch in there now, so we're running our bonds to multiple switches instead of single switches. So it's just an expense in terms of the extra switch in the rack, but
which isn't that expensive.
Right. Yeah. Nowadays it's just not that, and we're running cumulus switches that are like a couple of grand, so it's not really that big a deal, relatively speaking. So it's definitely become more tenable to do it, and it's as the cost has come down, and again, I guess it just depends on your workload, right? If I was just running all Ceph clusters and I set my rack level failure domain, I'd probably be okay with that. But for OpenStack, I don't know always what workloads are running on what computes and where, and things could be a row away for some people's applications, and they may not like to have have long interruptions like that and then just magically come back. And I can't control everybody's applications, and I can't worry about individuals as much, so I need to just kind of build for the worst case, and with the best with what funds that I have available. And so we try and take at least dual connected like that, and dual provider ISP wise, and multipath routing in the data center, so that we can kind of create that resiliency, but not go too nuts with it.
So actually, Eric, you bring up a good point, which is that I think that we're talking about sort of two different types of workloads. So you're talking about a workload where you don't have any control over the workload. It's random, right? It's sort of the public cloud model, essentially.
Yep. I mean, we have a private cloud, but we have multiple customers within it, so it kind of behaves like a public cloud in a way. I'm not provisioning everybody's things, and it's not all one application. It's lots of different applications running around, and like I said, I know there's a lot of like replicated data things in there, like Cassandras and Valeras and various things that get unhappy when they get connected from their friends for long periods of time and then just magically come back. And I'm not great.
Right, but you have to build in a way to support whatever random workload they put in, because you don't have any control over them.
Exactly. Yeah.
But in a telco world, we have a lot more control over the workloads. In fact, the data center, our data centers are tuned to support the workloads because we know what the workloads are. And we do typically, particularly in the networking ones, typically do know what the workloads are. So they're in support of our networking infrastructure.
I mean, ideally, all the HA should happen at the application level, right? You should not be reliant upon your underlying infrastructure as a developer, but that's, you know, unicorns and stuff. So
it's not really possible to say that HA happens at the application level if there is only one way for that application to connect, or one place where that application's information is stored. I mean, you know,
yes,
there is a shared burden, and I think that's the challenge of an application developer is you have to know what your target is in order to know that you've achieved HA. And as Beth sort of alluded to, their data centers are tuned in a certain way so that the people providing that software know what they're delivering into, and they can achieve the number of nines that Beth needs in her network. And I think that's the challenge in cloud. I mean, at the end of the day,
I think you nailed it. I think the question of the SLA, and if you expect that you can deliver the SLA simply looking at how you developed your application, I think it's somewhat missing the mark, because you have to have SLA of the, you know, call it platform or the cloud, and then there is SLA of the application itself,
Yeah.
or, you know, design of them, and you cannot, you know, deliver the end customer SLA without looking at, you know, the full picture.
Right. Well, and when people use public clouds, there's an assumption, implicit assumption, which is not in fact true, that public cloud has a high SLA, that it's not going to go away. But that's not if you read the SLAs of many of the public clouds, they're pretty much not there.
exactly, our cloud won't fail. I mean, we don't know what happens to your application, but the cloud's still going to be here. Yeah, that's not helpful.
Right, it's totally not helpful. So I just encourage everybody to take the poll. We have about 50%, a little over 50% have voted, so we encourage you to do it. Let's get there. Let's get to 90%. So moving on. So I had a question about diverse network, and somebody put in diverse routes versus diverse manufacturers. So that again gets back to hardware. So can we have a diverse software network? Is that even a thing?
Maybe rephrase the question.
Yeah. Well, maybe the question is, what is a diverse network? You know, what does that mean to you? And is it something desirable? I mean, from a telco perspective, diverse network is desirable. And as I mentioned earlier, diverse network to us means we buy some circuits from another telco, or we peer with another telco. That's what it means. That's what diverse networking means to us. That does not necessarily mean that to other people. Maybe we should just skip that question because it was just kind of.
All right, and this is Eric. I do have one thing to throw in there. I mean, the diverse manufacturers thing stresses me out. I do have some diverse hardware in terms of switching infrastructure, just because we run Cumulus, so we have a couple of different models of switches in there, a couple of different manufacturers, just depending on what we were able to source. But you know, from an administrative perspective, they all look the same. So it's not too much of a big deal. We try to keep it to a minimum to be able to have sparing and stuff like that around. So I just try to avoid the diverse manufacturer part of it whenever I can. So that's generally not been part of my diversity strategy. But the rest of it is
let me ask another question about that, because if in software-defined networking, theoretically, you've disaggregated the hardware, and so therefore the diverse manufacturing shouldn't theoretically not matter.
Well, I run both parts, so I guess it kind of matters in that way. You know, I'm running the SDN, but I'm also running the underlying network, so it kind of plan for both, I guess. But yeah, it shouldn't, from a cloud perspective, it shouldn't matter. You shouldn't care what's underneath, I guess.
That's supposedly the whole purpose of cloud, right?
I think as Eric was alluding to, SDN solves part of the problem, but what you want to avoid is diversity of operations, and manufacturers generally don't align on how things are operated.
Yes.
You know, you can get a common open flow northbound and everything else is different. It's not very helpful in the big picture.
Right. Well, and it makes HA that much harder. And we have a comment from Sia, which I'm not quite, could you explain in the chat? I wasn't quite following what you were referring to in this case. They might not be on voice. So the question is, in context of OpenStack, at the end of the day, the i3 agent is
L3.
Oh, sorry.
Layer 3 agent.
Oh, layer 3 agent. Okay. Oh, that makes much more sense than the question.
But it is a single point of failure, and
yes,
it needs to be engineered away or resolved. Yeah. I actually don't know. Actually, it's a very good question. Is anyone, the last session was really about the large scale deployments. Following on from that, is anyone in a large scale deployment using the L3 agent?
As far as I know, we're not.
Yeah, I'm not sure how much it's used in the telco environment. I'm not aware of any deployments that are.
My deployment doesn't count as large scale so much, but we do use it. We use L3HA, and it works fine. Got like three networker nodes, and it's been sufficient to handle our needs. But I know some larger scale folks that I talk to mostly either are running provider networks or they're doing things like Calico or other things like that. So yeah, there's not a lot of. Most of the really big deployments are not running the L3 agent that I'm aware of.
Yeah, I wanted to mirror what you said, Eric. This is John here. Yeah, we've certainly seen quite a lot of L3, but again, like a sort of delicate use of the provider networks for traffic that actually you don't want to go through the L3. So so an example from the scientific world is lots of like for the parallel file system, you don't want that going through an L3 agent. You kind of need the lower latency. So provider networks have been used there. I guess the question to the telcos, if you're not using L3, do you just have a single flat provider network generally?
I've never known a telco to have a single flat provider.
Yeah.
No, but I am wondering what the alternative is.
But I think, yeah, that's quite strongly leveraged in the telco world is the provider network. But yeah. I also know there's from an Ericsson perspective, we have a number of people we work with, and almost equally as many ways of solving networking. I mean, it really depends on the customer's networking or the operator's networking philosophy as to how that then sort of evolves into the data center and what tools you need to resolve for that. I don't think there's one button you can press and say solved. It's a complex space with a rich history and set of opinions. Sorry, go.
I guess a lot of people that are running really large deployments too. Some of them are running commercial SDNs, Nuage or NSXT or something like that. That really distributes stuff out so that that obviates the need for L3 agent as well. But running L3 agent in a kind of medium-sized environment is perfectly fine, and running L3 HA is great. DVR, I agree, has that problem where it's per compute node, but if the compute node heads and the L3 agent on it being fed, it's so much of an issue. But in the terms of L3 HA, it works like it's supposed to, because it's simple, stupid, keep alive D inside, and that just works. So
I suppose the follow-up comment is turning on L3HI with DVR, I think, is still marked as experimental.
Yeah, I've never touched DVR. Just I don't need. It seems like it almost feels like too much scatter for me, and takes up a lot of IPs. So.
Yeah.
I don't know much about
Hey
it.
guys.
Oh, excellent. Thank you.
Oh, I'm sorry for my problems. Okay. Actually, my question was that I think it was Eric that mentioned that the DVR consumes lots of IPs actually, and that's a lot problematic for us. In SDN context, I tried Open Daylight and honors controller. In high traffic rates, they're not actually work properly. And I like to hear about your experience in Verizon and AT&T about SDN controller and how you manage high throughput traffic.
Oh yeah. Yeah, we have. I actually don't know the details of how we're doing it, but I do know we do support high throughput traffic because we have multiple 10 gigabit switches going into it and support them with no trouble. But I don't know the details of how we're doing it.
Oh, I think you mentioned that you are using the provider networks.
Yeah.
And that means that you don't have any integration between the Neutron and SDN controller?
I actually don't know because I don't know the details of how that. I know more about the overlay than I know about the underlay.
Oh, okay.
So
I think that's a common model.
James yeah. So keep going.
Yeah, I was just going to say, I think it's a common model that your SDN solves for the networking side, and then what's happening inside the cloud is the responsibility of Neutron. And generally, no, not generally, but I have seen quite a lot that there is a network management operational support system that coordinates, and the two are not coupled in any way. And it's just a separation of domain and separation of responsibilities, and that is a pretty common model, I would say.
Yeah, that makes sense.
So I don't know if James is on, but he can answer more about what we're doing in the underlay. So I would like to move on a little. We have about 15 minutes left, and want to move down to some of the other questions we have. I think we've covered how important is networking HA in a data center. So I'd like to talk a little bit more about it in the edge environment, because I think that's a very different environment. And I think that how you do HA in the edge has to be a different way. I know our experience is that our customers are asking for HA at the edge. We have those edge boxes that support networking applications. And when we originally rolled it out, we did not have an HA strategy. And that was probably one of the first things that our customers were asking about. Well, can we get HA at the edge. And so we ended up doing a number of things to make it work. We have application HA. We take advantage of many networking applications and firewalls, and as a perfect example, have HA built into their DNA, so to speak. And they do full stateful HA. And they but we also do it with dual boxes. So the idea is the HA, you know, we assume a box failure is the like in the data center where it's a rack failure, we assume a box failure. We did make a deliberate choice not to put dual images on a single box. We felt that was kind of silly and expensive, given that the box it's not a rack of stuff, it's just a box. So we made the decision that the HA, if the customer wants HA, it's spread over 2 boxes, and then it fails between the 2. So, any other thoughts about, you know, how to address edge is it possible to do HA in a mesh form, or, you know, some other way that isn't specific at the local level? And please note that poll is ending. So Erin, should I end it? Okay, she just did it.
Got you.
Thank you. Thank you, everybody. Looks like upgrades, biggest pain. But I think we heard that yesterday too. So that is clearly within the, and it's interesting. HA did not get high results. I'm curious as to why that is. But clearly there's a lot of people who are interested in HA because they're all on this call. So, thank you for the results. So any other thoughts about you know, HA at the edge? Should it be treated differently? Should those edge nodes be treated as cattle that can disappear at any time and presumably come back? What about HA networking, you know, out at the edge? So typically our response is we require a out-of-band access for those boxes. So that if the box fails, you know, we can still get into it and kick it. To you know, if it gets into some race state or something.
Beth.
Yeah.
Prakash here. Yeah. Interesting. You talked about the pet cattle and the pet here, but at the same time, if we can have a radio peering at the edge over there, that could be a way to preserve the state. Of course, we do want stateless, but that's going to be a challenge all the time, especially with the state transition being managed through Kubernetes. We still need some kind of a, what do you call it, the edge, kind of a persistent volume to maintain and transfer the state like we do in the radios, like prepare and then execute and make sure that handover happens. Something very similar, we need something on the edge, I believe. Now, I don't know, it's a out of box thinking, but that's a possibility because we never hear about radio peering. We only talk about fixed line peering in the ISP's world or in the large scale at the multiple edges. So I don't know what you think on Verizon side of it. How does it work? It's a pet cattle. How do you handle that?
Pets. Yeah, that's a good question. And that brings up, you know, the LTE deployments, the radios. The radios have to be considered cattle. You know, if a site goes down, the signal has to be picked up by its peers. I can't imagine it's done any other way.
That's right. That comes down to radio planning and how you make sure you have coverage and yeah, you don't try and solve resiliency with a bunch of optical cables going to one antenna. It's just not helpful.
No.
But yeah, to be honest, when you were asking the question, Beth, my brain was running okay on-prem. I mean, if I have an on-prem solution, let's say it's something residential, then generally I'm plugging into a cable box, and when that goes down, I want to make sure I have some sort of LTE
Right.
5G thing picking that up to make sure that it still kind of works. Maybe I can't do my HD streaming at that point, but I don't lose the functionality. If you move if you move a little further along, and then you come to that peering point, you've got the curbside box. Well, the curbside box, unfortunately, it's very hard to get multiple connections into there as well, and there you have what is essentially a single point of failure for a very small number of people. You move up a little bit further to some sort of a peering point, and then you're generally on an optical ring or something equivalent, and there you will have multiple devices and multiple cables coming in, and that's where you'll start to have site resiliency. And we build and we architect for these things, right? So it's really a question of what is Verizon's philosophy when it comes to how you want to address some of these questions. What are the best practices and how do you want to apply them? And then you sort of go from there and make a number of decisions around how to establish resiliency in the network. And what changes then is what software you deploy at different places to support the needs that you have based on those decisions that you've made. And it's really hard to, without a picture in front of us to say this is how it's going to look, to talk about what softwares we need here or there or elsewhere. And I think that's one of the challenges we have in especially when it comes to network HA. So many options, so many choices. And they come down to, am I on an island? Am I in a city? Am I in a remote place? That then you have different decision functions driving how you build an architecture, which is eventually results in what is the software I'm deploying there changes accordingly.
Well, and also where in the network and how the network is architected is going to affect where you put the resiliency.
So, Chris and Beth, I am reminded of M2M at the meter reading, where we used to have a SIM which will be a backup for over the air to be able to implement many of the use cases. Something similar. So you always have a SIM over the air as a backup for fixed line connectivity. In M2M.
Yeah, it's a good resiliency system.
Right.
Yeah.
Yep, that does. That makes sense. Well, I think we're down to the last 5 minutes, right? It goes till 1400. So, so I know we only managed to get about halfway through the questions. I guess that's good. So I bring up what OpenStack components are important to networking HA. Obviously the tools in OpenStack are limited to Neutron and Nova, but that's just the OpenStack components, and do they support HA? How well do they support HA, and can we consider adding some new features to make them better? And we talked about L3 already. So again, I open it up.
I was hoping someone that knew something would speak here, but I actually have a similar question. I know that OpenStack, we have a bunch of good tools in place for how we're running OpenStack workloads, how we're spinning up VMs and so on and so forth. And I know we have emerging and developing tools for how we best support something like a Kubernetes or a platform as a service layer on OpenStack, where all of a sudden the workload pieces are sort of removed, but the infrastructure itself still needs to provide those mechanisms. And I have a lack of visibility, I think, in how well we are addressing that, and how our tools that we've developed, which are great tools, are emerging and evolving to support where you don't have as much visibility into the application need. It's generally abstracted through some platform layer. It would be great if someone had some insight into that specifically. I'd be very interested to hear.
So, Chris, as far as I know, Heat has got the capability if you have networking, but that's provided somebody can debug, which is very, very hard to use. And Heat Stack is the real difficult portion of it to even trace anything there. It's very complex. So I have not heard of any tool whereby we can do a network HA. I have not really.
Yeah. I always find that we end up doing it at the application level or at the box level. We're not doing it at the OpenStack level, particularly.
So, just wanted to bring up anti-affinity rules. I don't know if people make use of those heavily. There's definitely scheduling issues at scale with anti-affinity rules, so they get turned off. But
yeah,
that's something that comes up.
So anti-affinity rule, my comment about anti-affinity rules is they work great in a large data center. They do not work at all if you only have a couple racks, or if it's at the edge. They literally don't. They're completely moot. So they do work better at larger scale, but yeah, we turned them off because a lot of our sites were too small to really take advantage of them.
Yeah, they certainly work better when the cloud is empty.
All right. I have popped in, Beth.
Yes, that's fine.
That means that I think we're wrapping up, if you're good with that.
Yeah, it was great conversation. And we only got, as I said, we only got about 1/3 of the way through the question. So that's always a good sign, right?
Yeah, the Etherpads will stay up. There's lots of opportunity to keep collaborating after the event, which is one of the things we aim for here, is to get people connected, figure out what the topics are, and then keep working for a long time after. Awesome. Well, thank you so much to Beth and everyone. We had so many great comments and great engagement on this topic. So we're going to take about a 10-minute break. We really cut the break super short last time, so we're going to try to go for a full break here. So we're going to come back at 10 minutes past the hour, so it'll be about 9 minutes, but that'll be a nice break. So Aaron, if you want to roll the break slide and the amazing music that you've selected for us, we'll be coming back for the next session here in about 9 minutes.